if I write some numbers like 5319072 and I'll add one more digit and 7415317. Okay. So how do you add them? If I talk about adding both of them, how do you add them? The traditional method is that we add 6 plus 7, it becomes 3, and then 1, then 1, 1, 2, it becomes 4, then 7, 3 becomes 0, then 6. This is how we do. That was the traditional method, right? Now, because you are going for such a prestigious exam, and it's more about calculations. It's more about calculations than ever. So you should be able to do these type of calculations by adding two numbers at once, right? So do not add a single number. Add two numbers at once. Okay, like 26 and 17. This should be clicking you in just a second, half a second. Okay. So 26 and 73, 17 will give you 43. So 43 is simply this, right? We don't have any further carry here, right? Can you do this? Then we have 7 and 53, it becomes 60, right? So do not add single digits. Try to add two digits at once. Okay. 19 and 41 will become 60 again. That's luckily that's a very easy calculation. And 53 plus 7. Oh. So that's just coincidence, students. I have not done it knowingly. So that becomes 60, 60, 60 and 43. That's your answer. Okay. Suppose I write 7, 5, 1, 7, 6, 8, 9, 2, 8. And 2, 1, 4, 5, 6, 7, 3, 0, 8, 0, 7. Something like this, right? So what do? You take two numbers at once, right? It becomes 35, right? You can do it. I mean, the addition of two numbers is not a very big thing. You should do it. Okay. The addition of two-digit numbers. Okay. Then 89 plus 73. So this may take a little bit of time, but still try to do it. See, if you want to do 89 and 73 quickly, so make any one of them as 0. I mean, either make this as 90 and this as 72. One from this is transferred to this, right? Now you just have to add 9 and 7, right? That becomes 16. So it will become 162. Getting something? Right. So see, this is a calculation technique based session. So not very conceptual, I would say. And your answers are also not very much relevant because you can do the answers in maybe 5 seconds or 7 seconds just by normal addition also. But the thing is, try to switch to these methods, the faster ones. They will help you. Okay. If you want to add 89 and 73, make it 90 and 72, and that will make it 162. Or you can make it, you can make this also as 70. So if this is 70, 3 is subtracted from here. This becomes 92. So just transfer that extra 3 to one of the sides and then add. So this will give you 162. Getting my point? So somehow this can be done. So this is 162. Now again, what do? You take two numbers at once, and this is 62, and now the carry is 1. Now the carry is 1. Okay. Now you have to add 76 and 56 and this one. Right. So if I transfer this 7 to this, all this you have to do in your mind. 76 and 56 and 1. So if I transfer this 7 to one of the side, so this will become 70 and this will become 63. Is it clear? So you have to add 70 and 63, it will become 133. You just have to add 7 and 6, it will become 133. Right. That's how, the typical CAT student should add or should subtract. Is it clear, students? Okay. So,
yes,
so 76 and 56 was 133. So 33 here. And we'll have 1 here, right? Now 51, 52 and 14 will give us 66, right? And we have left with this 7. Okay. Next thing that you should do daily on a daily basis is take two-digit numbers. For example, I take 37 and 79. Okay, I'll take two of the two-digit numbers, 37 and 79, for example. Okay, what I'll then do is I'll perform 4 or 5 operations on this. Okay, the first one is their addition, then their subtraction, then their complements, then their half, and their doubles. Okay, this will benefit you a lot, students. What you need to do is you need to do this exercise 5 times in a day. Okay, take 2 numbers, both of 2 digits. 3-digit you can't handle right now. Take 2-digit 2 numbers and randomly just write without thinking much. Right, you suppose you write 61 and 47. Just don't think much and write 2 numbers and take their addition. The first thing is their addition. So the addition of 37 and 79, again, if 1 is transferred to this, it becomes 36 plus 80. This is much easier to handle. Okay. So this will become 126. Addition would be 126, right? 116. Okay, it was 36 and 80. Subtraction. So you want to take out the difference. Now this is easy, I think, because 3 and 7 is 4 and 7 and 9 is 2. So this is easy. Just take the difference of this, 42, right? And then the complements. So complement means subtracting it by 100. 100 minus 37 and 100 minus 79. So these are the complements. Okay. So complements in this case would be 63 and 21, right? Then the halves. So we need to divide both of them by 2. Simple. So divide both of them by 2. This will give you 18.5. And this will give you 39.5. Correct? And their doubles. So 37 into 2 is 74. And 79 into 2 is 158. So this exercise, these 5, the complements are 100 minus this number. Samarth. Okay? I just told. 100 minus 37 is 63. 100 minus 79 is 21. Okay? So these are the 5 exercises that you should do on the daily basis and on the 5 numbers daily. Just take random 2 numbers, right? You can take like 71 and 43. That's it, right? Try to take a hard number, right? And do these exercise daily. Do this for next 10 days and you will see the difference. In the next 10 days, you will be able to cover 50 pairs, okay? They may have same digits, same numbers sometimes, but still, from those 50 pairs, you'll be able to learn a lot about these basic calculations. So addition, subtraction, complements, halves, doubles, that's it. Okay. Is it clear, students? Learn the perfect squares. 1, 4, 9. The series should be completely there in your mind. 1, 4, 9, 16, 25, 36, and so on. And you should have, you should be, knowing the squares till 25, and just not knowing, it should be there in your mind every time, right? You should be able to do this very quickly, right? If I ask you the square of, suppose 19, it shouldn't take even 1 second for you to tell me that the square of 19 is 361. Okay. So that level of, it's like table. Like we used to mug up the tables in our school. So that same thing you should do with the perfect squares. Then we have perfect cube. So 1, 8, 27, 64, 125, and so on. Perfect cube, I will give you some relaxation, and it's okay if you remember the perfect cube still 12 only, right? Do you know the perfect cube of 12? The cube of 12, simple. Anyone quickly? सुमित वो 144 इंटू 12 भी करना होता तो फिर वो तो मैं ही कर लेता, फिर तो हम 12 इंटू 12 इंटू 12 भी कर ही लेते, right? Okay, so you just had 1 second, 2 seconds maximum. In those 2 seconds, only Suryadeep was able to give me the right answer, and that's 1728, right? I know that you'll be able to calculate the cube of 12 in 15 seconds or 30 seconds or 20 seconds, right? We can always do that, right? But it's just that we have to do it within a second. So it should be marked up, okay? So the perfect cube series should be there in your mind completely, okay? Then we have the perfect, the prime number series. The prime number series should also be there in your mind, okay? Yeah. So the prime number series, 2, 3, 5, 7, 11, and so on, okay? And the prime number series should be marked up till 100, okay? Right. Do you know how many prime numbers are there till 50? How many prime numbers are there till 50? You don't know. So 15 prime numbers till 50 and 10 prime numbers. 10 prime numbers between 50 to 100. So that makes it total 25 prime numbers till 100. Okay. What is the value? What is the nature of 1? 1 is neither prime nor composite. 1 is not a prime number, neither a prime number nor a composite number, right? The perfect definition of prime numbers is that the number should have exactly two factors. Okay, all those definition that the number should be divisible by 1 in itself, the number should be divisible by 1 and the number, all the other definitions are not valid, not perfect. Okay, this is the perfect definition that the numbers which have exactly two factors are prime, and the numbers which have 2 plus factors, more than 2 factors, are non-prime or composite. Okay, 2 factors prime, 2 plus factors composite. Okay, so these are the as you can see, definition. These are the number of prime numbers, right? 1 is the only natural number which has only one factor. It has only one factor. It doesn't classify in this category or in this category. Okay, so that's why it is neither prime nor composite. Okay, so prime numbers, you have to learn till 100. Till 100, you should be able to tell all the numbers, about all the numbers, whether they are prime, whether they are composite, and in composite also, whether they are divisible by 3, whether they are divisible by 5, 7, or 11, right? 13 also. Okay. After that, it's fine if you don't remember for 17 or 19 also. But for each number, you should know whether they are divisible by these numbers or not. Okay. So that's about the prime numbers. Okay. Now, one more concept, that suppose I write a random number, which is a very large number. Suppose I write 7, 33 here, 733. I want to check whether this is a prime number or not. Okay. How will you check it? Would you keep on dividing this number by all the prime numbers till 733? You will divide it by 2, you will divide it by 3, you will divide it by 5, you will divide it by 7, and so on. But till when? Last date? No. Sakshi? That's a very bad answer. Last date doesn't tell you whether this number is prime or not. Okay. So 733. I want to check whether this number is a prime number or not. Till what value I will divide this? Using the that's not a perfect definition, sort of. See, 6n plus minus 1 are the prime numbers, right? But not all. Not all. Okay. Every number who is of this format are not the prime numbers, but all the prime numbers are of this format. After 2 and 3, all numbers would be, all prime numbers would be either 1 more or 1 less than the multiple of 6. Okay. And that's a simple thing. That's a very simple concept. Nothing, nothing fancy in it. Nothing to learn, nothing to mug this up. See, if a number is, suppose 6n plus 2, obviously it is divisible by 2, right? If a number is 6n plus 3, it is divisible by 3. If a number is 6n plus 4, it is divisible by 2. for sure. So the remaining numbers are only 6n plus 5 and 6n plus 1, right? Obviously, 6n is also divisible by 6, right? So the remaining numbers are only this and this. So a prime number has to be either 1 less than the multiple of 6 or 1 more than the multiple of 6, right? But every number of this format is not a prime number, right? 49 is not prime, right? 65 is not prime, right? Obviously. Okay, so coming back to 733, how will you calculate? How will you determine whether this is a prime number or not? So you will divide it by 2, you will divide it by 3, you will divide it by 5, 7, but up to what place? Up to what number will you keep on dividing this, right? Obviously, we can't go till 733, right? So till what number we will be dividing it? What do you say? No one knows this? Okay. So let me tell you that you need to divide it till the approximate square root of this number. Okay. Can you tell me which number has the square near about 733? Which number has the square, has its square near about 733? No. 9 has the cube, Kashish. 26 square is 676. 27 square is 729. Okay, this is nearest. But it's okay if you take 26 also. It's completely fine. Right? Even if you take 25, it's also fine. Okay? Because we don't need to check its divisibility by 26 and 25. We need to check the divisibility till the prime number less than 27. Okay, so you will check it. You will check the divisibility by 2, by 3, by 5, by 7, and so on up to 23. If this number is not divisible by any of the number from the given numbers, so definitely it will not be divisible by any of the number coming after this, coming after 23. Have you understood? I'll give you one more example. Suppose I take 471 as a number, and I want to check whether this number is a prime number or not. Okay. So I'll check this number, although this is divisible by 3 only, right? As you can see. But still, if I want to check, if I make it 473, suppose, right? And I want to check whether this number is divisible by any number or not. Is it a prime number or not? So take the approximate root. So the root of this number is near about 24. So still you have to check till 23, right? Because 23 is just behind this number. 23 is just behind this number, right? So you have to check till 23, and even if you get one number which divides this number, right, you can declare that this is a non-prime number. This is a composite number. Is it clear, students? So the complete concept was just that if you want to calculate if you want to check whether suppose 383 is a prime number or not, so you just have to check it till the square root of this number. The prime numbers till the square root of this number. So square root of this number is approximately 19 point something, right? So you just have to check till 19. next thing that I can tell you is about the squares. So you remember, always remember that that a square can only end with 0, 1, 4, 5, 6, and 9. That's it. A square cannot end with 2, 3, 6, sorry, 2, 3, 7, or 8. Okay. So suppose I ask you what would be the suppose I ask you whether 1683 would be a perfect square or not. So just by looking at the unit digit, you can tell that this is not a perfect square. Okay. All right. Am I clear with this, students? It is not a perfect square, right? If I ask you whether 2027 is a perfect square or not, no. It cannot, a perfect square cannot end with 7. Okay, so that's why this is not a perfect square. All right, let's move ahead. So this you have to remember. Okay, and it's a simple thing to remember. Obviously, see, we have 0 square as 0, 1 square is 1, 8 square is 64, 2 square is 4, and 5 square is 25, 6 square is 36, and we have 7 square as 49. So you can quickly, if you have the squares in your mind, the basic squares, you can quickly guess this. Okay, now let me move to the square roots, the approximate, the exact square roots of the perfect square. See, the first topic in this series would be, we will guess the square root of the perfect squares, and then we will try to calculate the square roots of the non-perfect squares as well. Okay, we'll do both the things. Okay, so square root of the perfect square. Suppose I write a number like 4096, and I want to check whether this is a perfect square. I know this is a perfect square, not want to check that this is a perfect square. Okay, got it? Now I want to know the square root of this number, right? And it should be done in 3 seconds. So what I need to remember is, for this, what you need to remember is 10 square, 20 square, 30 square, 40 square, right? 50 square, 60 square, all these squares you should remember, right? And obviously that you can remember by adding 2 zeros to all these numbers, right? 1 square would be 100, 2 square would be 400, 3 square would be 900, 40 square, 30 square would be 900, 40 square would be 1600. I hope you can remember this. 50 square would be 2500, 60 square would be 3600, 70 square would be 4900, 80 square would be 6400, and 90 square would be 8100. Right after that, 100 square becomes 10,000. So that's a 3-digit number. I'm not going into 3-digit right now. So that would become 10,000, right? So this you have to be, this has to be there in your mind while doing this. So quickly, just analyze that between which of the values does this number comes. So if you want to place, if you can place this number between some of the values, it will come between 60 and 70, right? Is it clear? So the square root of this number has to be between 60 and 70, right? And then look at the unit digit. Just look at the unit digit. Okay. So 6 comes in the square of which of the numbers? So 6 comes in the square of either 4 or 6. Okay. Okay. So it can be the square of 64 or 66. Okay. Now the final step you have to do yourself. Okay. How that you can do, how you can differentiate between 64 and 66. See, most of the time you will be able to differentiate for sure. Okay. But some of the cases like this is a complex case. You have to segregate these two numbers, right? So how can you do this? How can you segregate between 64 and 66? Which number would be the square root of this? Okay. So just try to find a factor. Just try to imagine a factor which is which belongs to one of these. Like 64 is entirely dependent on 2. Okay, it is 2 to the power 6. But when we talk about 66, it has 11 in it. So just try to divide 11 from here. I mean, just try to divide the square with 11. Because if 11 is the factor of this number, 11 will also be the factor of the square of this number, right? So if it is not divisible by 11, the answer will be 64. If it is divisible by 11, the answer would be 409. The answer would be 66. I hope this is completely clear, students, right? Any doubt till now? Okay. This was a little complex actually. We can have answer is 64. We can have even more easier ways of doing this. Suppose I have a number 1681, right? Can you calculate? This is a perfect square. Can you calculate the square root of this number? We can use 65. No. Calculating the square of 65 would be difficult, right? 1681 is a square, right? So how will you calculate this? So it's 1681, right? It comes between this and this, right? And the unit digit, it can either be of 41 or it can be of 49, right? But as you can see, the upper limit is very large, 25, and the lower limit is very small, 16. Okay, right? So it should be closer to 1600. Sorry, it should be closer to 41 or 40 than towards 49, because see, 50 square becomes 2500. So we cannot have such a large change just by changing one digit. Okay, done. So that you can guess. How can it be 49? It cannot be 49. Abhinav, that's what I'm saying. Because 9 square is also having the unit digit as 1. But still, we can figure out that between 1600 and 2500, all these squares of the line 40 to 50 varies. Okay. So the square of 49 has to be very near to 2500, then the 1600, right? So that's why 1681 root should be 41. Okay, done. Now we move to Just some of the common multiples also, multiplications also, I would like to tell. See, if I need to multiply x by 5, okay, something needs to be multiplied by 5. So make this 5, write this 5 as 10 by 2, because when you will multiply it by 10, it will, you just have to increase one digit, 10 in it, and then you can divide it by 2, right? For example, if I want you to calculate the something like 123 into 5. So it would be difficult if you multiply this 123 into 5. It may get difficult, right? What you can always do is 1230 by 2. This looks easy, right? Is it clear? Okay. And again, if you want to divide this number by 5, then again you should do 123 into 2 by 10, right? Into 2 by 10. In this case, you just have to multiply these two numbers. So 123 into 2 would be 246. And divide by 10, you just need to put a point here. Got it, students? Anything that you need to multiply with 5 should be changed to this kind of thing, right? Okay. Some more things. If you want to multiply, the corollary of this could be, if you want to multiply something by 25, you can multiply it by 100 and divide it by 4. Would be easier, right? If you want to divide, again, divide would be the same thing. If you want to divide a number by 25, so you can always multiply that number by 4 and divide by 100. Okay. Will make it a lot easier, right? Suppose I give you 165 into 25, right? How will you do it? If you have, if you don't have, if you don't want to get into the multiplication of all this, so just write it 16500 and divide it by 4. That's it. I think that would be much easier to do than multiplying it by 25. Correct? Right? Similarly, if I want to divide 150, I'll take 155 only because I've written this. If I want to divide 155 by 25, okay? So that would be 155 into 4 by 100, right? So now you have to multiply by 4, okay? So multiplying by 4 will give you how much? 620. Divide by 100, 6.2. Got it? Okay, can you now visualize that how easy can it become? Okay. And obviously, there is a simple rule about the squares of any number which contains 5. So suppose we have 25. And if you want to calculate the square of this, okay. If you want to calculate the square of this, so what you need to do, you need to write 25, okay. And you need to multiply the 10th digit. You need to multiply the 10th digit by a number greater than 1 greater than this. So 2 into 3 should be written here, right? For example, if we want to calculate the square of 65, okay. So 25 should be written here, and then you should write 6 into 7. So that becomes 4225. Okay, are you able to understand this? Okay. 95. So 95 can be 25 and then 9 into 10. Right? So that becomes 9025. Okay. Clear, students? That's the basic rule, right? This is something that you all must have read somewhere. Okay. Now let's move to the square root of a non-perfect square. Now this is going to be fun. Suppose I square root. Suppose I want to calculate the square root of any random number that I write. I write it as suppose 827. Okay. I want to write it as 827, right? For this also you need to, you need to have the exact squares in your mind. Then only you will be able to calculate all this. Okay. So 827 square root has to be found. So we need to calculate, we need to know the square of the number. I mean, a perfect square just before this. Okay, 827. So what can you say? Which number will have the perfect square just before 827? Acha, one more thing, students. Before actually going into this, let me just give you one more concept. That if I take any of the series of numbers 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay. And if we want to take the square of all of these. Okay. So if you know one of these square, you can calculate the square of this or one more number from this. Like this is 400, this is 900. Everything should be between 400 and 900, right? Now 21 square is 441. A lot of you should know this. The square of 24 is related to 21 is related to 29 and 29 square is 841. The last two digits would be exactly same. Okay. Then 22 square is 484. So the square of 28 will be 784. Okay. The 23 square is 529. So 27 square would be 729. 24 square is 576. So 26 square is 676, right? And this will become 625. Okay. This is valid in all the numbers, all the numbers between like 20, 30, 30, 40, 30, 40, 50. It is valid. Okay. Suppose I want to check it for 10, 11, 12, 13, 14, 15, 16. No, it is not valid for this. Only the unit digit would be same in this case. And that is a very simple thing. Okay, leave it because the line from 10 to 20 will only give you the unit digit. And that is that can be easily determined just by looking at the unit digit. So it's not required. But it is valid in this case. It is valid around 25. It would be valid around 50, right? Any number which is less than 50, suppose I take 47. So the square of 47 will have the last two digits same as the square of 53. Okay. It will also be valid near about 75. The square of 73 will have the same last two digits as the square of 77. Okay. So it is valid about 25, 50, 75, 100 as well. Okay. So all these numbers you can see. Okay. So now coming back to this root of 827, you need to calculate. What you can do is, tell me the perfect square just before 827. So that would be 784. Can I write this as 784? Just a second, students. So can I write it as 784? Acha, you want to calculate the difference of 827 and 784, right? So here's how you can calculate the difference also in a super fast way. So this is 27 more than 800 and this is 16 less than 800. So it is always better to add 27 and 16 than to subtract. Okay. So it is 27 more. See, we take a level 800 and 827 is 27 above this and 784 is 16 below this. So just add 27 and 16. You will get the difference of 87 and 784. Okay. So that comes as 43. Okay. So can I write it as 43? Right. Okay. I can write it as root of 784 plus 43. Okay. Now understand that write the root of this number 784. So the root of 784 would be 28. Correct. And we have to add, remember, 43 divided by twice of this number. 43 divided by twice of this number. So twice of this number would be 56. So it would be somewhere around 28 plus 43 by 56. So just calculate this approximately. Yeah, right? You just calculate this approximately. So 14 into 4 is 56. 14 into 3 is 42. So this should be around 6 or 7, right? So that would be 0 point something, 0.77. So the square root of this number is 28.77. I think I've given a tough value in the starting. Right? We have divided. This is the root. See, this has actually came from a square plus b square plus 2ab. Okay. So anything that is extra, we divide by 2 because we multiply by 2 in the formula. Okay. We don't have to get into the derivation of this, right? Just understand that if we write something like root of 160, okay, so root of 160 is not a perfect square, as you know. The perfect square just below this is 144. I can write it as 144 plus 16, right? Then I can write it as 12, right? Plus 16 needs to be divided by twice of 12. So that's 24. Okay. So this will make it 12.66. That's almost the root of this number, right? Obviously not the perfect one, but almost very, very near to the root of this number. You can use the calculator and calculate the exact root of this number. Exact root of this number 160. So it will come as 12.64. Right. According to the calculation, according to the calculator, it is coming as 12.649. So that's around 65. So that this can give you the approximate root of this number. Okay. Now, students, you have to practice all these things. You take the random, you take the random numbers, you write at least 3-4 random numbers, right? Take the square root of those numbers and do it on the regular basis. uh, Even if you don't do the square root, right, you can try the square root maybe after this class or maybe till tomorrow, right? That would be great. And after that you can forget it. You can, I mean, you can, you don't forget it, but you can afford not to try it, because as the square roots, the questions will come. If you have tried 10 questions maybe till tomorrow, then in coming week, if the question will come and will ask you about the square root of these numbers, so you will be able to apply the same concept, right? But the concept that I told you in the beginning, the addition, take two numbers, add them, the addition, subtraction, complement, then difference, uh, doubles and halves. Okay, all these things you have to do it, you have to do regularly, right? For the next 10 or 12 days. Okay. Also, start adding the numbers by taking 2 digits at once. Okay, take 2 numbers at once and start adding all of them. So this thing and this thing you have to do on the daily basis. Okay. For the remaining shortcuts that I have just told you, you can always have this recording, ask for the recording, keep this recording with you, right? And keep revising this in maybe 15 days. The calculator that is given in the exam is actually a trap. Okay. Do not use that calculator, right? Do the 95% of the calculation on your own. You can use it for 5% of the calculation, where it is typically written to calculate 517.73 into 23.5. Something like this is written. Then you can obviously calculate using the calculator, but otherwise don't. Right? It is a very basic calculator, on-screen calculator. It is a trap, so that you see that calculator and you focus on the calculator only and you forget anything. So in the exam, if you see the calculator and if you have a habit of calculating through the calculator, so in the exam you would be doing 3 into 5 by the calculator only. So it's a trap. You should not fall for it. Okay. They give you the basic, very basic calculator, in which even typing the digits is, takes a lot of time. So it actually waste a lot of time. Okay. You can do the calculation yourself faster than typing it. Okay. All right, students. So I hope this is clear. Right. Ending this class. Bye-bye. Good night.